Dirt Smart, tips and techniques for irrigation technicians, helping you save time and money. System startup. Here is the outline that we will follow in this video. Use this process anytime you're filling an empty piping system. Maybe because it's a new system, maybe it's a spring startup, maybe you had the system drained down and repaired a break and now you need to fill it up again. We want to use a maximum pressure of 50 psi and a maximum velocity of less than 2 feet per second. So the velocity is the speed that the water is flowing in the pipe, and it's determined by the pipe size and by the flow rate from our water source. So here in this little chart, if you look at the 6-inch pipe size, the GPM, the gallons per minute, is 150. That gives us a velocity of 1.73 feet per second. So that gives us an idea of what we have to stay under. We want to keep these two numbers down so we can eliminate pockets of trapped air that could be compressed. The pressure is much higher than normal because that gives personnel safety concerns, and it also reduces the possible damage to the system. Next, we will identify the locations of vents we can use to let the air escape. They could be sprinkler heads at high points to turn on and off and remove the inside parts. You can see from this little diagram below here. There's a little tool that can be put on and it keeps the nozzle in the upright position. It could be quick couplers at high points where we'll put quick coupler keys in. It could be air release valves. That is their job, to let the air release. Or winterization hydrants where we can open the valve and let the air out. On this illustration, the arrows point to each one of the air vents and to where the air release valve and the winterization hydrant are located. We have arrows pointing to all of our drain valve locations. Identify the highest and lowest elevation points, and we also want to identify any mainline piping dead ends that we're going to have to address separately. Next, we want to figure out how we can slowly fill the system at low pressure. So in your particular system, you might be better off zoning off portions of the main line and filling the course in sections. You'll also want to maybe sequentially close the high point vents first, allowing the compressed air to force water out the low point drains. And that might come in very handy, especially if you have long runs that are dead ends on the main lines. It's important we figure out how our pump station can help us slowly fill the system at low pressure. Is there a pressure relief valve we can utilize? Or can we adjust a frequency drive on our pumps or our outlet valves to control the flow and pressure while we're filling the system? Are there pressure gauges that in the field we could take out to monitor, such as putting a gauge on a quick coupler key? And can we communicate changes in the field back to the pump to ensure that the pressure and velocity stay within the recommendations? So our first step, we're going to open the drain and vents. Now we don't want to compress the air and then relieve it. We want to let the air bleed from the system while we're filling it with water. At all low points, we want to open designated drains. At high points, we want to open designated vents. And we want to repeat that process for any mainline dead ends that we might have. It's now time to get our pump ready. 50 psi maximum, velocity rate of less than 2 feet per second. We've got our plan ready and we're ready to go. Now we're going to work through the process. So we've got our pump running and we're going to work through the process. Monitor the flow of air and water. Once we're at water and no air, we'll shut the drain valves off, remove those air vents, and move up to the next higher elevation. Shut those drain valves off, and we're going to move to higher ground and repeat the process as we move up the landscape from lowest to highest, keeping in mind any dead ends as well, until we get to the very top or the very last spot where we've got air coming out, and our job on the main lines is now complete. Now we want to go back and purge air from the laterals by activating the sprinkler heads. So same pressure guidelines, same velocity guidelines. We're going to start at the low spots and turn on a given number of heads so we don't exceed those velocities. and then work our way through the lowest to the highest. If we find a sprinkler head issue along the way, it's a great time to flag that sprinkler head. And now we've got 3 flagged here on a little illustration. Get all the way up to the top of the hill. Now everything's purged. All the sprinkler heads had water coming out and the air pockets were removed. Last step would be to address those sprinkler heads. Okay, the job is almost done. The last step is to bring the system pressure up to normal. So we're going to go from that 50 psi maximum, and we're going to now increase it up to line pressure. We should be able to do this safely at this point with no harm or damage done to the system. The information from this video came from this resource document called Irrigation System Winterization and Pressurization Procedures from the Toro Company. You can Google it, or you can reach out to one of us and we can get a copy of it for you. And always, if you have any questions or we can be a resource for you in any way, reach out to somebody at Store Tractor Company or Turf Equipment and Supply. Dirt Smart. Tips and techniques for irrigation technicians, helping you save time and money.